They work well enough to point the Hubble where it needs to go, though.
Mm-hmm.
Oh, they work. There's no doubt about that.
Yeah. Okay, we can probably get going. Good evening. Welcome to the January 30th Astro Cafe. And tonight we've got a pretty short list of things, but I think there was some bylaws that need to be discussed. Is that correct?
Yeah, thanks, Brock. I just wanted to first of all say I hope everybody got the email from Jill yesterday announcing a special general meeting on February the 13th. So in a couple of weeks. At that meeting, we are going to present the draft or the bylaw amendment that has been prepared by a subcommittee of the center, and have a vote on whether the assembled members so agree to adopt it. So we will start our normal Monday night session with that. Is basically the Jill included the motion, I guess, that will be put forward, or the resolution will be put forward, and attach the document, so how it is now and how it is changing. And Jill, I don't know, did you want to say anything further about that?
No, just if anybody wants a copy of the red line version that shows, you know, underlined and struck out the provisions as they are now and how they're going to change, then just contact me and I'll send it to you.
Thank you. Yeah, so basically, so we're hoping that that will be fairly short, because it's essentially a yes or no vote, as long as we get a quorum, but we do need to have at least 25 members present. So please do attend that night if you're at all able. And then following that, through the efforts, I believe, of Jim Hesser, and we are going to have Sarah Ellison speak to us. Is that correct, Jim?
Actually, it's due to the efforts of Randy, but Sarah, and it's Sarah, not Sarah.
Sorry.
I once said Sarah to her, and she corrected me. But Sarah has agreed to give a talk about her galaxy research, but adding something about Leavitt's law and you know, coming out of the play. But Randy approached her about actually giving the talk she'll give after the 5 February matinee, but she said that was just too simple for a group of serious amateur astronomers. So she's going, apparently she spoke to our center about 2015, was a little worried that maybe everybody wouldn't find it interesting, but there are so many wonderful and active new members. It seems like a really great, it will be a great talk. You know, it's really worth coming to vote on the bylaws.
Good. Lauri has a question.
Yes, I just wondered, Jill, if we are not able to make the meeting, can you do a proxy?
Yes, you could give me your proxy. You can give anybody your proxy. If you have instructions on how to vote, include them in your proxy. That you have, it has to be a member that you give your proxy to, but that would be really appreciated, because we do have to get that 25.
Is it something that has to be in writing?
It has to be in writing, but it doesn't, an email will do.
Okay, thank you.
Hey, so are there any other questions? So that's the 13th of February. Great. Okay, thanks. Back to you, Brock.
Okay. So Dave Payne had mentioned he had some Comet related material. I don't know if it's stuff he did or stuff that he just wanted to share.
Sure, Brock. I will just share my screen here. So the past 2 nights were nice and clear, although cold. On the first night, I took some images of the comet with a long focal length, larger telescope. And last night I switched over to a smaller refractor to get the whole comet. So I haven't actually processed and come up with final images, but I did put together a couple of videos that are kind of neat. I thought I'd share them quickly. The first, well, I'm going to show this. This first was a series of 102-minute, 120-second images. The comet was actually moving backwards in right ascension, I found. So the result was when you track the comet was a doubly blurred star. So the stars you'll see as streaks. But as I was imaging, you can see the stars move to the right. But of course, and there's the comet in the middle, as if going through the stars there.
Really nice.
But I went to a shorter exposure because I did want the stars, and I want to put the stars back in the image when I finally process the comet. So this is a bit. I've got 200 of these images, so we'll just scroll through them. At least this one, the stars are round. You can see the comet traveling through the stars. And it gives a nice display. I have to work on the noise and all that stuff, but and stack them. But, makes for an interesting view of the comet traveling. But during, of course, when something crosses the meridian, it usually forces your mount to have to flip and put the weights on the other side of the mount and start imaging again. Well, later on, in early hours of the morning, my mount came up against a hard boundary on the meridian and stopped tracking altogether because I didn't know how to, but also I didn't tell it to do a reverse meridian flip because things aren't normally moving.
Yeah, that's a weird.
Towards the east. But yeah, it's that's all I had. Just thought I'd share that.
What length exposures were you using? Those say 8 seconds, is that right?
These ones are 8 seconds.
Okay.
The original video I showed you was 2 minutes.
Okay.
So in those 2-minute exposures, did you notice any change in the shape of the coma?
That being the head, is that what the coma is?
Yeah.
Well, none that, like, I haven't actually processed it, but I couldn't see much change in the middle. I think the tail might be wiggling a little bit. But it's hard to say what's just difference in aberrations caused by lighting effects and what's really a change in the comet. It wasn't nothing as dramatic as going on as with the last comet that I can't remember the name of the last comet that went by. That it was all looked like there was chunks falling off of it and things like that. Nothing as dramatic as that.
Did you use the updated version of the Comet process in PixInsight?
Not yet. All I had time to do today was calibrate all the images and throw them into a video.
Okay.
So Dave, you're very particular on scientific details, right?
Yes, sir.
So chunks don't fall off a comet.
They don't?
No, there's no gravity to make it fall.
Or melt off.
Melt
Just
off or fly off,
drift away, drift away.
drift away, that's right. I got you, Mona.
Well, there is some gravity.
Teeny weeny bit.
Good. Thank you very much. Those are great. I can't wait to see the end result. I thought I was pointing in the right direction and I just had stars and I moved around and I don't know what, I must have messed something up. But 20-second exposures weren't enough to bring anything out, so it couldn't have possibly been on target. So, but it was a big rush. I just dragged everything out quickly and I probably didn't get my alignments all proper.
I don't know. This is a difficult one to see in my experience, whether you go all the way back to Holmes or some of those. They were easy to see. This one is just a pain in the butt.
I think it's got so much notoriety because of its extraordinary long period, orbit period. I think it's 50,000 years or something. So I think people have got a bit caught up in that.
Yeah, the media hasn't done us much of a favor. I still go back to Neowise in the summer where I was up on Christmas Hill and an aircraft came and just crossed whatever it needed to start a contrail behind it. And people grabbed their phones and took a picture of the thing and said, "Oh God, we've seen it." And then they turned around and left.
Very good.
Nice.
Yeah, I wouldn't say this is a terribly exciting visual comet.
No.
Kind of just looks like a buzzball, but seems to photograph quite nicely.
Yeah, the photos look good. Okay. Margie, did you have some angular momentum stuff to discuss?
I do. Every day I look at the APOD, and of course terminologies come up, which I don't understand. So one of the recent APODs within the last couple of days used the words angular momentum. So of course I had to look it up. So we'll give this a go. So share screen button. Okay. Whoa. Okay. Click on desktop 1 and press share. Okay, move participant faces and hide them. We'll see how all this goes. Okay, where's our... All right, can you see that YouTube screen?
Yes.
What is angular momentum? Okay, here we go.
Physics, at its most basic, is just a description of the motion of the stuff in our universe. This planet goes this way, that rocket goes that way. Except that some, in fact many objects, move without moving. Or more precisely, they move without going anywhere. I'm talking objects that spin, revolve, rotate, pirouette, orbit, circle, gyrate, whirl, twirl, cartwheel, and so on. Like a planet around a star, an electron in an atom, or even our solar system going around the gravitational center of the Milky Way. From up close, they're certainly moving, but in the grand scheme of things, that motion doesn't take them anywhere. We can still talk about it though. Just like momentum is a concept that describes how much oomph an object has when it moves in a straight line, angular momentum is a way to account for how much oomph objects have when they're going in circles, figuratively or literally. And angular momentum is simple in theory. Pick a point, any point. Pretend your object is moving in a circle around that point. Figure out how fast the object is moving along the circle, never mind that it probably isn't moving exactly along the circle and that the circle might have to change size over time to follow the object. But anyway, then multiply that speed times the size of the circle and the object's mass. And there you have it, angular momentum. For example, a 2 kilogram, 60 centimeter diameter bicycle wheel going 20 kilometers per hour would have an angular momentum of about 7 kilogram meters squared per second. Is that useful to know? The reason we care about angular momentum is that if you take a bunch of objects that are interacting electromagnetically or gravitationally or whatever, and add up all of their angular momenta into one number, then that total value won't change over time, unless some other objects from outside come in and mess things up. So as another example, the Earth, which is 150 million kilometers from the sun, orbits at 30 kilometers per second and has a mass of 6 times 10 to the 24th kilograms, has an angular momentum of 2.7 times 10 to the 40th kilogram meters squared per second. That's 4,000 quintillion bicycle wheels. And this angular momentum stays roughly constant over the course of the Earth's orbit, year in and year out. But what's amazing is that even if the sun and the rest of the solar system were to suddenly disappear, the Earth would still have that same angular momentum about the point where the sun was. Without the sun's gravity, the Earth would of course now move in a straight line, requiring an ever larger imaginary circle as it got farther from the point where the sun used to be. But as the Earth continued through space, its 30 kilometer per second velocity would also point less and less along the circle. So when you calculated the angular momentum, the decrease in velocity would exactly cancel out the increase in the size of the circle, and you'd always get the same answer, 2.7 times 10 to the 40th kilogram meters squared per second. So even when nothing is rotating at all, angular momentum is still conserved. And that's the beauty of a law of physics. It works, even when you try to break it. This video is brought to you in part by Audible.com, the leading provider of audiobooks across all types of literature, including fiction, nonfiction, and periodicals. If you go to audible.com/minutephysics, you can try Audible.
There we go.
Very
Exciting, huh?
illuminating.
Very good description. Thanks, Margie.
I have a question. That last point was pretty interesting.
That's why your gyroscope stays straight up.
I have a question.
Go
for
ahead.
Margie, so your angular momentum of your bicycle wheel is conserved. So what happens to it when you stop the bicycle?
You go flying forwards. Let me see. I don't know.
You get rid of it through heat, through the brake pads.
Oh, you're being nasty.
However, if your bicycle wheel is massive enough, that's one of the things that helps keep your bicycle upright. Is you roll down the road, you can jump off the bicycle and it'll keep going in a straight line as long as the wheel has massive enough.
Hang on, if you put the brakes on your bike and no heat was lost through friction, wouldn't your angular momentum go into the Earth and exactly add to the Earth's rotational velocity?
Even if you have
Yes.
kinetic energy loss through friction, the angular momentum goes into the Earth, exactly. So that the angular momentum remains conserved.
Everyone just bike all the time, we can eventually get rid of leap years.
Oh, what a great idea. You should do a calculation to find out how many
We just all
bicycles
have
we
to
would
bike in
need.
the same direction.
Yes.
Dave, you have a comment or question?
So I've always, I've just wondered about what happens to the angular momentum of an object as it falls into a black hole. So if it goes to a singularity, then it has no radius. So the angular momentum has to go somewhere.
Mhm.
So the black hole can't have zero radius.
Oh, that's interesting reason.
Yeah,
Well,
it's,
one figures out what one divided by
that's a
two.
tough one to get your head around.
How can, Dave, but a black hole rotates though.
How
So
do you know?
it must have angular momentum.
So does it add to the angular momentum? But it can't if it doesn't have a radius. I would assume the black hole takes in, and if it falls in the right direction, it will speed the black hole up.
Well, I think I heard somewhere that rotating black holes don't have a single point singularity because points have no angular momentum, but they have, what was it, a ring of infinite density that rotates along one axis,
So they have a size.
size but no volume. I don't know how that works really, but they can rotate.
If it's got no volume, it can't have a radius.
So
Yeah, on this point, Jim, when I was working up there, I went and talked to the black hole expert, in his office and I said, how do you know that the black hole is a singularity and it doesn't have some actual diameter? And he said to me, we don't.
Yeah.
That's what he said.
So
So I was quite surprised to hear him say that.
another question might be, if all that infalling matter to a black hole, maybe it loses its angular momentum when it gets to the Schwarzschild radius, and that's why we see those jets coming out of either side of a black hole.
How would that preserve angular momentum?
Because it's transferring it to outgoing particles
But where's the angular momentum?
from whatever's falling in on it.
Ordinary momentum isn't necessarily angular.
Yeah, but if they're circling a black hole, they would have.
But you're saying it's shooting out from the black hole.
I don't know the answer.
No, I don't know.
I don't think anybody does, quite frankly.
Yeah. We're getting into some fringe math. on
Perhaps no one here, unless Jim would like to say something.
Yeah, how was your trip in South Africa?
Just in case you're interested, that angular momentum video was angular momentum for kids. So I thought it was just perfect for me.
Perfect for us.
Perfect.
It's a hard concept to have get around your head sometimes.
But that last little bit he gave Margie about the Earth going in a straight line and angular momentum still being preserved, that was pretty sophisticated stuff for kids.
Yeah. Yeah, it would be hard.
Yeah. It was hard for me anyhow.
What I now know is that angular momentum and momentum are not the same thing.
Yes.
Must be a momentous realization.
And it's actually one of the biggest impacts of angular momentum in astronomy is for things like when stars turn into white dwarfs and stuff, the angular momentum of the, or a neutron star or something like that, that angular momentum of the star's mass is conserved when it shrinks into a neutron star. So in order, it's just like a figure skater pulling in their arms. The spin has to increase, and this, when you imagine something like a sun just turning slowly when it becomes a neutron star, the spinning is just astronomically fast.
It can be like a thousands of times a second. It just, it's almost beyond belief. So I have a question for somebody smarter than me. So this guy said that the angular momentum was preserved if the sun just disappeared and was going in a straight line. But if you just arrived after the sun had disappeared and saw the Earth going in a straight line, you would just say it would have momentum. It would just simply have momentum. So aren't they indeed the same thing in that situation?
Yeah, they are. Pretty much. It's just, you're just switching from a Cartesian coordinate system to a radial coordinate system.
That's a very good way of explaining it. Good. Yes, right.
Fox said those stars that collapse and start getting faster, that's the reason we have millisecond pulsars.
Mm-hmm.
Yeah, that's what we were saying.
Yeah.
Good discussion, Margie.
Yes, thank you. Anybody else have some great physics discussions you want to have?
I have something.
Sure.
If kinetic energy is preserved, because of course energy is preserved, and angular momentum is preserved, where do they both go when you stop the bicycle?
The energy,
The angular momentum is conserved, but it's conserved in the whole system, including the Earth. So when you stop the bicycle, it means the Earth spins a little bit the other way, but it's a pretty small amount of spin for the Earth.
And
the
what
energy
about the
goes
kinetic
in.
energy?
that goes into heating your tires and your brakes.
It can be converted to other energy.
Yeah.
It's the same thing with linear momentum. If you leap up into the air, so you get some momentum, the Earth gets an equal and opposite amount of momentum in the opposite direction. The same kind of changes happen for angular momentum.
Thanks, John.
Another bit of interesting stuff is most things, its momentum is their mass times their velocity. But light photons have no mass, yet they have momentum, which is really weird.
If I may make a point there,
But they do have mass because energy and mass are really the same thing, Dave. So it's not quite correct to say they have no mass when they've got energy.
No, they don't have mass, or time would stand.
They don't have any rest mass. But they have
Yes.
They have energy, which is mass,
Yeah,
as a result of their motion.
but E doesn't equal mc squared. E equals mc squared plus momentum times the speed of light. It's a term that's dropped off a lot of times.
I might make a point about light having momentum. When you run it through the relativistic mass increase, well, light should have, any object with mass moving at the speed of light should have a mass of infinity, and light has a mass of 0. And somehow, when you multiply infinity and 0 in the momentum equation, mass velocity, you somehow get some actual real number for its momentum. Not that that makes sense, but it certainly
It's a Dirac delta function,
sense.
if you want to look it up.
Okay, you guys, you're getting carried away.
Yeah, really.
Time out. And I believe what John had to say. After all, he's a physicist and all that kind of good stuff.
Is there anything else, anybody, any other subjects or anything else anyone wants to share tonight?
Is this called the Physics Cafe now?
I don't know. Astrophysics.
Astrophysics, good thing.
We can make it whatever we want.
Yes,
That's right.
that's true.
Good discussion, though.
I want to point out that the sun, rotating as it currently does, also has an astronomical rate of rotation.
Isn't it like 5 days or something?
What's its rotation period?
It varies by latitude. Yeah.
That's weird to think about.
The sun also has what, did you say?
An astronomical rate of rotation. It doesn't obtain an astronomical rate of rotation merely when it becomes a neutron star. It has it now, because by definition.
Oh, yeah, for sure, yeah, okay, okay.
That's all I was needing.
May I change the subject?
Please do, Lauri.
No, let's stick to physics.
Okay.
Of course, you can change the subject.
All right, Lauri, go ahead.
We had a really kind of fun evening on Saturday with the Friends of the DAO. We had an Astro Jeopardy quiz time, and we had Ben Dorman and James DeFrancesco and Dan Posey as our contestants that were being quizzed. And James won, so there you go. But one of the questions that came up that is still, I'm still not sure exactly of the answer, is which planet has the most moons? And there was a discussion as to whether or not it was Saturn or whether it was Jupiter. And I'm wondering if anybody knows that. Because at one point it was like Jupiter had a certain number and then Saturn got a whole bunch more. And so it was more, Saturn had more. And now on Saturday, people said, no, Jupiter's now got more. Because they found a whole bunch, they found some more, and so now it's above, now it's like 92 or something like that, and Saturn is about 87. I'm just wondering if anybody knows anything about that.
Well, whoever asked the Jeopardy question must know, because you start with the answer and then the person has to give the question.
Well, it depends on where they got their information.
We make a rule that like astronomy textbooks not include the number of moons that Jupiter or Saturn has, because they'll be outdated before the end of the year.
Yes, that's true. Yes. Do you know anything about this, Nathan?
Well, I would say that Saturn has several trillion moons.
Yeah.
Good point.
Well, yes.
That's all the particles in the ring.
But then again, Jupiter also has a set of rings, so who knows?
It depends what you call a moon.
Yeah.
Yeah.
I mean, like,
Right.
If this website is true on NASA at the moment, they're saying it's very close. They're saying Jupiter has 80, 57 confirmed and 23 provisional, and Saturn has 83, 63 confirmed and 20 provisional.
provisional.
I guess the ones they think are moons, but they haven't confirmed. I guess they've got to confirm they're in the orbit and etc.
When does a dust particle become a moon?
Yeah, that's a good question. Yeah.
They should have crashed Cassini into a ring particle to create more moons.
So that Jupiter could win.
Oh, right, yeah.
The International Astronomy Union has a definition for planets. Do they have one for moons? I don't know.
That was the question, or is it like?
Yeah, a mass or whatever. It's
Maybe.
minimum.
Yeah, minimum
And if
mass.
they do have a definition, is it entirely arbitrary?
Yes.
Yeah. So it's not getting far, right?
It's certainly arbitrary for planets. It would have to be arbitrary for moons.
Yeah.
If it looks like a moon, it is a moon. I would go with that.
So I guess the next time we stand in front of the classroom and the kids ask which planet has got more moons, I'm saying, well, we don't know.
They both have lots. You
They
just
both
don't.
have lots. Yeah. Okay. Thank you.
Yeah.
You can always turn the question back to them to research.
That's always a great approach. Yeah.
Which one do you think has the most? Yeah.
Right.
How do they define a moon? That's a
And
good question.
if you take the artificial bit out of the equation, we do.
So Lauri, you can tell the kids to go ask their mom. That would work.
Moons are satellites. They're
Yeah.
satellites and moons.
Well,
There's
there's
even
some.
a verb definition to moon.
No,
What if you-
if you take the artificial. You could determine it.
Could be a short night tonight for us. I don't know if there's any other subjects. Are there any announcements or?
I have a question.
Yes.
I believe John gave a presentation this afternoon to the Berwick crowd because I have a friend there, so she told me. And I would like to know what your presentation was on. What was the topic?
I talked about astronomy in Victoria. I thought they might be interested in the fact that Victoria has been pretty active in astronomy, both professional and amateur, for a long time. So I talked to them about Plaskett and the building of the telescope, and then his work to find the motions of the stars that make up the Milky Way, and how he measured the size of the Milky Way and the rotation rate of the Milky Way, which was quite an important advance at that time. And then I talked about some of the things that have gone on more recently, like being involved in, DAO scientists being involved in making the first images of planets going around other stars, and the formation of stars in the ring around a forming star. And then I went on to talk about what we do in the RASC group, I talked about the outreach stuff that goes on. Probably many of you would have your ears burning if you were listening, because I talked about lots of you. And I told them then about what some people are calling inReach, where we do things to help people who are in the group learn to do more with their hobby than they might have done by themselves. And I ended up by talking a little bit about the play that is on right now, and the wonderful woman who helped us learn how to measure the universe. So that was what it was about. I had an amazingly good audience. This is now the 5th time I've spoken at Berwick, and I'm still kind of a little bit in awe of just what a good audience I'm getting here. The people are, they come from all different walks of life, but there's a lot of very intelligent people here who have done, many of them have really interesting past lives. And so the questions have been really good. And they seem to like it. They want me to do more of these things. That was the last question. When are you going to do the next one?
And Calvin and I did about at least 4 presentations during the pandemic before you joined there, John, and they just wanted something all the time, and then they came up twice to come up to the center. And so they just have this immense thirst for anything that is in that realm. It is really amazing. The Berwick group is the best I've ever spoken to, bar none.
Wow.
The thirst that you describe is a very good way of saying it, because they really do have that thirst. And by the way, they talked about your visits when I first came. People were certainly still remembering those. So yeah, it's good.
I have a question for Jim and for John. Jim, we were the first at DAO to intentionally image a planet circling around a star, correct?
Christian Marois, as part of his PhD thesis, which was done at Université de Montréal, did that, yes. And he came immediately to DAO upon completion of his thesis.
Yeah, he gave a talk which I attended, but however, a couple of days later, did you know that the astronomy picture of the day said, no, we took it first. And they showed a picture taken by Hubble, and they pointed to a little arrow with a speck in it saying, there it is right there. Now that we know it's there it is.
I was not aware of that.
Yeah. I thought they were pretty good until they did that, but anyhow.
Cheating to use Hubble.
What's that?
It's cheating to use Hubble.
Well, see, the problem is they didn't know that they photographed it, and they were trying to take credit for it, you see.
Oh, they didn't discover it then. They just.
No, they didn't. They didn't, but
it.
they were saying they did. I almost wrote them and said, that's not fair, you guys. Come on, smart enough.
Well, Marwa did the research.
Yeah, he did.
We all know that. And his team.
Yeah.
First published.
Yes, definitely first published.
Well, it's certainly fair game to go back into archival data to find previous measurements of a newly discovered object.
Yeah.
My recollection was that Christian showed the picture at the Moon Underwater pub at one of our Christmas get-togethers.
He did.
I think you're right.
It was an exclusive. We weren't to publish that because it
Was that right?
It was 3 or 4 days before it actually debuted.
Yeah, I agree. That's exactly what he said at the time.
Yeah.
It was pretty amazing to see that thing.
Yeah, we were privileged for sure.
Now, Jim, correct me if I'm wrong, apparently he was pretty fast on his feet when he discovered this thing. He said that the way he discovered it was by turning off the rotator on the telescope, so the planet turned into a streak. Otherwise, he might not have been able to see it. And he was thinking on his feet, and he actually told the technicians, turn off the rotator, and they didn't know why, but he did, and then he saw it. It was pretty clever, like thinking on his feet right there at the moment.
He is an exceedingly clever individual.
Yeah. I was proud of him anyhow.
For the record, getting back to Berwick, John, how many Galileo moments were there today?
I didn't do a count, but there's typically about, I don't know, 35 or so people come. There's a lot of people here. There's also an awful lot of activities going on, some of them overlapping and whatnot. But that's probably a bigger crowd than you get for most things. They seem to really like astronomy.
Okay. Any other subjects? Sounds like we're
Just if you're interested, there are some how to use stellarium courses being given at the national level. I think there's stellarium 1, 2, and 3 in the app, something like that. So if you're interested in some of those, you can go in and find out about those. And there's also the Explore the Universe from your own backyard kind of thing tomorrow at 12:30 our time. If you're interested in Chris Vaughn and Samantha Jewett are work on those on every second Tuesday at 12:30 our time. So those are
Lauri,
things
would
that are
those be
coming
on
up.
the national site or?
Those would be on, they'd all be on the national site. Yeah. If you go there and go to virtual activities, or just go to Explore the Universe, it'll come up, and the stellarium courses will come up if you go to oh goodness, help me out.
Lauri, I think they were in the this week email that came out this morning.
Yes, if you go right into if you just go into the newsletter that was sent yesterday, this morning, all the stuff is there as well. So yeah.
Good, thanks. Well, I think I don't know. It sounds like we're running a bit dry on.
Bill has something.
Bill's got something.
Yeah. So I can't remember when Reg asked me to talk to Pearson about picnic conversation of starting up what used to be an annual event when I first joined the center. Would people be more interested in a spring or a late summer one? It's kind of the concept. Spring might be difficult because they're getting into exams and stuff like that. And then as soon as they're finished exams, like late April, early May, they boot out of here. So that one might be hard if we want some of the students to be up there to sort of be involved and get to know the people there that do the astronomy program. Or it could be towards late August.
Late August.
And then they probably wouldn't be there.
Late August is the star party.
What's the date of the star party?
11th to 13th.
Oh, I'd be talking like the last of August.
Well, that was ruled out because of the Sandwich Fair,
which is September, right?
Labor Day weekend. Wherever it falls this year.
I think there's a window of opportunity in late August.
Yeah, between the two.
It's probably a better chance of better weather.
Yes.
What about July?
Right.
It's a picnic, not an observing.
There's no observing allowed?
Well, you could
So-
fish and stay, but it's.
Oh, yeah, there's a ton of
It's a
scopes
social
out there.
activity, you know,
Depends how late you want to stay, I guess.
you could stay
And stay
late if you
later,
want.
yeah.
Yeah, late August, you'd have a little bit more chance to maybe stay around and see something in July. You'd have to stay around till 11 or something.
I think it's a great idea.
Yeah, I do too. Nice place.
So it's thinking more about probably late August. I'll figure a window.
Yeah, it looks like the Labor Day weekend start, the 1st of September is the Friday, so it's that
Oh, so
quite
it's early.
early, yeah,
Okay.
early in September this year.
Okay. We'll figure it out. It was nice out there last night. I was trying out one of their new Quest stars, weird little scopes. I haven't quite figured it out, how to use it as a finder yet. I had to put it beside my other scope so that I could line up on the Comet and see the angles and the directions until I could figure it out and get it in the eyepiece. It's really nice on the moon, but it's a 3.5-inch scope.
Are they Matsukovs?
Yes, so it's quite a narrow field of view,
Yeah.
but they're interesting because it's all, you put one eyepiece in and then it's just little flip levers to make 2 different magnifications or turn the scope into a finder scope. I couldn't quite figure out how to get that way to work. So,
And they're really expensive.
yeah, they inherited some stuff from a guy that, well, they have 2. One, I priced it somewhere around the $2,500 range, and the other one is like even used 10 grand. It's the 50th anniversary one.
Yeah, right.
They're a collector's item, yes.
Yeah.
I think that's what it is. Does Chris Gainor have anything interesting to say about JWST or anything?
Chris Gainor is mute and invisible.
I guess not.
He's coming online.
No, I'm here. So I've had a bit of a rough time of it the last couple of weeks. I came back from took a little vacation in California after I was at the American Astronomical Society, and I came back with some sort of infection. So a week ago I was in the hospital, and now I'm out, although you can see I'm still, not ready to roar out the door with my telescope. But I am getting better, and yes, so I'm here, and I think I got a couple of, while I was in Seattle, I got a couple of goodies for Bill and a couple of other people. But yes, I'm just kind of getting back into the groove with various things. So I don't have much to say about JWST. I was able to see a couple of presentations when I was in Seattle, and I mean, it was just, euphoria. Everybody was so happy with the results they were getting. So anyway.
Get better soon.
How many people attend that conference in Seattle?
About, I think I have the numbers here somewhere. Just give me a minute. Okay. More than 3,400 astronomers, students, educators, and journalists gathered in Seattle for the 241st meeting of the AAS. So yes, there were some talks. Just a minute. I think I took a couple of pictures while I was down there. give you an idea what it's like. Just a second. I gave a talk there at the historical session, and there might have been, 40 or 50 people. Just a minute.
Bill, do you have a question for Chris?
But not for Chris, it was a general question because I can't remember when's the AGM, our AGM. Have we
Tentatively, so the special general meeting is February 13th.
I know that one.
The annual general meeting will be March 13th, so they are the month apart.
Okay.
That is the plan at the moment.
Do we have a speaker yet for it?
The AGM will probably be business only at this point.
Business only, okay.
Yeah, we'll see, because that does take quite a bit of time.
Yeah.
Oh, Chris found his pictures.
So some of the things you can do at these meetings are do things like visit exoplanets, and it's just they have all these stands like a trade show, and they give away things, and I was actually there myself signing books. Let's see, how does this work? Oh, okay. This is a little less user friendly than I would like. Anyway, okay, and I seem to have lost the share screen. Share screen, why is this so big? Just a minute.
Yeah, the problem is stuff gets covered up on your screen.
Okay, just a second. Gotta try again. Okay, where's the share screen? Yeah, I was signing some copies of my books down there. NASA shipped them down there. And I signed some copies. And there's a couple of other pictures I wanted to show. Just give me a minute while I fight this out.
How many books did NASA ship there?
Oh, actually not that many, about I think about 100 copies.
Gosh,
So,
you would think just about everybody would want one.
Yes, they went pretty fast. Okay, so it opens and then it decides to open up way too big. And okay, here we go. So this is like one of the opening lectures, and there's where it was one of the project scientists from JWST. I've just forgotten her name off the top of my head.
Jane Rigby?
Beg pardon?
Jane Rigby?
You're right. So this was like the first morning, and actually this picture doesn't quite convey the size of the crowd, but this was quite a big room. You know, you'd be hard pressed to find a room that big in Victoria outside of something like the hockey arena. But most of the seats were full, so she was giving a talk about the latest things from JWST. Just let me see what else I've got here. Okay, just give me a minute.
Jim, were you down this year?
No, I decided it just wasn't worth taking the risk.
Okay.
Too many people in a small volume. Well, it's that convention center is huge, but just didn't feel like going.
Okay.
But I think, and something I didn't realize before, but Chris could correct me, but I believe they actually enforced a mask protocol.
Yes. Yes, they did.
If I'd known that, I might have been more tempted. And I have heard from a few people who came down with pretty serious COVID sometime during their visit to Seattle.
Oh dear.
Just a minute, what? Yes, so by the way, the ill health I'm dealing with right now is not COVID or anything respiratory, and it's probably something I caught in California rather than Seattle. So, and then they have a trade fair thing here. You can see, like, NASA has this huge booth, and they're giving away posters and buttons and magnets and you name it, various other gewgaws, and at kind of on the left side there, you can see what they call the NASA hyper screen. So they're making presentations there and for groups of people who were interested. And I was for a couple of hours during the meeting, I was signing things on the other side of that hyper wall. And let's see, do I have anything?
Does that mean you were on the other side of the wormhole?
That's right, you got it.
That's where you got sick.
Could be. Could be. So just a minute. Okay, and let's share this one. So this is one of the other presentations at the historical event where I spoke, and Peter Broughton, who we all know, received the award for the best book in historical astronomy for the past year for his book on Plaskett. So
North Star.
Yes.
so that was good. And yeah, so I think I'll leave it there.
Thanks, Chris.
Okay.
Thank you.
Brock, we haven't seen David for a while, so is he well or is he away? Is he?
That's
What's
a good
up with
question.
David?
I haven't heard either.
Anyone know?
He's been under the weather as well. But improving. Yeah. But it's unusual for David not to be
Yeah.
part of this. He has no voice. He totally lost his voice. So yeah.
Then tell him we asked about him.
Yeah, there you
Yes.
go.
Yeah, if I can email him and tell
Good for you,
him.
Margie.
Yeah. I just wanted to say, Chris, it's quite amazing that when you think about all the work that you did for Hubble and all that history, I mean, it's still there. And it's still working all the time. And yet you were in the history section rather than in the, what's happening today section, right? So.
Well, I mean, there was actually a lot of Hubble presentations made in the what's happening today section,
Okay.
although, it was pretty clearly overshadowed by JWST.
Yes, yeah.
But there's lots of results. I mean, most of the people there are astronomers, and I'm not an astronomer. I'm an historian, so it makes perfect sense that I was where I was. So I actually gave a talk about Canada's involvement in Hubble, and a lot of it actually has to do with the story of the Canadian Astronomy Data Center. And Jim and various people have been helping me with that. So now there's a kind of a written version of it, which is going to be in the February JRASC, which should be out any day. But I have created a presentation on it, which I probably be willing to present a little later on.
We'll get you.
Yeah, so it's the story is the DAO, and the DAO is one of 3 places on Earth where you can get all the Hubble data, or JWST data for that matter. The other 2 places being in Baltimore and in Spain. And it's kind of an interesting story of how it happened. When I first started in the book, I had the story completely wrong. And I went to see people like Dennis Crabtree and Jim and JJ Cavallars and all that, who told me how this came to be. And it also so we have this unique data resource, right up on the hill there. We drive by it as we go on up to the Plasca telescope, and but it's quite important for a lot of astronomers. And it also has something to do with the fact that we have an internet here in Canada. The development of the internet in Canada wasn't just, oh, the Americans have it, let's plug in. It was somewhat more complicated than that. And some of Jim's gray hairs there, I think, result from the creation of all that. When they were creating the Canadian Astronomy Data Center, it was there are a lot of things going on, and some of them involved governments cutting budgets for reasons best known to themselves, and leaving people like Jim to cope with it. So anyway.
Okay. Lots of good discussions tonight. Any other subjects, or should we wrap up? And sounds like we're done.
Time to
Thanks,
go.
everybody.
Thanks very much.
Thanks, Brock.
Thank you.
Good night.
Thanks, Brock.